Hi everyone, LCC 150D, Statistics for Informed Decision Making. We're looking at Chapter 5. This is Part 2 of the weekly video. We're going to continue where we left off from Part 1. And as you recall, we're doing regression line calculation. Just a quick reminder of what we were doing last time. Here's the equation. This is how to find B and find A. I told you that we can find this by using our Excel sheet. So we will be doing that today and looking at a couple other examples. Here's an example of how to do this. This is in your book. This is a calculation case study of regression. Per capita gross domestic product, that's GDP, and average life expectancy for countries in Western Europe. And you can see here are the stats. Here's the data. The GDP of each country is listed here, and the life expectancy in years is listed here. And so what they do is they do this long process, and this is the equation that you would have to do. Again, we will show you that you don't have to do this equation. And in fact, you saw it in the last video, but we will be doing it again. So this is what you'd have to do. I don't need you to have to do this. Okay? You don't need to do that. But you need to understand what you get at the end. We talked a little bit about R squared, which is a coefficient of determination. And the R squared explains what percentage of the variables are explained by the regression line. We'll give an example of this. And a couple of things about correlation and regression. They only describe linear relationships. Outliers can really affect these numbers. We'll look at a couple of examples of those as well. And you always plot the data before interpreting. Okay, so you have to make the graph, you have to find your results before you start making decisions. That's why it's called stats for decision making. Not just it feels like it's close. Extrapolation means that you extend beyond the range of your explanatory variable, your X, your independent variable, and I'll explain what that means in a couple of minutes. Lurking variables. If you've ever done an exercise in science or you've done some more studies, and as you keep reading these research articles, you'll see lurking variables means that other things could be happening here. If you did a study of children in a classroom and you gave them a specific test to do to see if they would improve their grades, sometimes you may have other variables, such as they may be very good students in the first place, or maybe they're not so good students, or else maybe there's another type of test that they were taking at the same time, or other conditions as well. Even a fire alarm during testing can be a lurking variable. So sometimes these things can cause a real problem in your decision making. Finally, association does not imply causation. That's similar to correlation. Just because things are correlated doesn't mean one causes the other. Okay, here's the extrapolation mark. This is a graph of age in months versus height in centimeters. And this is your range here from 30 months to 65 months. So this is your range. So this is a girl, Sarah. We want to find out what's her height plotted against her age. Predict her height at 42 months. So here we go. We go height over here. So 42 months. And we find right about 42 months, you can say that you can predict her age right about here. Now, can you predict her height? Her height at this age. Can you predict her height at 30 years, which is 360 months? 30 years, which is way off the charts here. And so that would mean this keeps going. So she keeps growing and growing and growing and growing until she's 30. Can you see why extrapolation? Extrapolation means you're finding data outside of your X region, your range. Okay, so that's outside of the range. So if you did the equation, use the equation and so on, you would find that at 30 she's going to be 6 feet 10.5 inches and growing. Don't forget. So that's why you cannot always extrapolate beyond the range that we have, the original range, which is back here. So that's what that means. Lurking variables, again, you have explanatory response variables here. So meditation and aging. Here's the idea. General concern for one's well-being may also be affecting the response. So observe meditation practice and the level of age-related enzymes. So in other words, if you meditate, does this affect your level of age-related enzyme? Well, you know that there are possibly many more variables, other reasons why you may get a certain answer. So these are lurking variables. And again, correlation does not imply causation. We've talked about this before. This should make sense now. So that's why you have to be smart and use your own decision-making abilities. And then here's an example. Does lack of social relationship cause people to become ill? There was a strong correlation. Or are unhappy people less likely to establish and maintain social relationships, reversed relationships? Or do they not even bother getting into them? Or is there some other factor? These are all lurking variables. So you have to talk about them. Be smart. Show off. Brag about it. So these are other things, and you can look at the properly conducted experiment establishes the connection, and that's a chapter 9 thing. We'll talk about that later. But the association is strong and consistent. So these are things that you have to look at. So take a look at this, leave it up here for a couple of seconds, and you can help yourself by looking at these things and thinking when you read an article, when you do some data crunching for your stats assessments or whatever, you can figure out that there's a lot of other variables. And so it's very difficult sometimes to figure out if you've got a very good set of data that says what it's supposed to say. This we'll come back to. This is an article. I'll give you an example of how a research article in the medical profession is very similar to what you probably should be doing for your own research articles and possibly for your own art paper that you'll do at the end of the semester. So I want to do an example from the book. And here's the book. And we're going to do 534, Sisters and Brothers. So how strongly do physical characteristics of sisters and brothers correlate? And these are the data of height in inches. So we have brothers and sisters. So we want to find the correlation, and we want to find the regression line. And we also want to find the equation of the regression line. So we're going to go to our here we are. Took me a while to find it here. This is 534. So here are the pieces of data, and I want you to make it look like this by the end of the session. So the first thing we're going to do is we're going to highlight the data, and I put it in this fashion here. We usually put them in columns, but I put them in rows just to show you that it can still work. So it's no big deal. Let's insert a scatter plot right over here. Scatter plot there, just like correlation. So we have something over here. So here they are. Now, as you know, for every single thing that you do, we're going to change that. So I'm going to, in fact, I'm going to cheat here. I'm going to copy this, but you should write a very clear and definitive title, and I can't copy it. So I'm going to just see what you learn when you try to do these things. So I'm going to put down characteristics, if I can spell it correctly, between brothers and sisters. Okay. And I'm going to make this a little bit bigger because I like big graphs. And if you send me big graphs, I'm happy because I have very old eyes. Some of you know how old I am from last week's tutorial. Alright, so here we have something, and as you know, I want some side here. Now, which one is this? Well, let's look at the numbers. Over here we have 58 to 70, just about there, 58 to 70. And over here we have 64 to 74. So you have to be aware that this is probably the sisters, and look at the numbers they are. So this is the sisters. So I'm going to back off here, and these are the sisters' heights, and the units are in inches. And let's fix the guys. These are the brothers' heights, and that's in inches. Alright, here we go. Now, we have the chart. This is the correlation. Now, you want to find a correlation? Let's go back to a cell. Do the same thing we did for chapter 4. Put an equal sign. Okay, I still have correlation up there. If you recall, you can go down the menu, find statistics, so on. But if you use this quite often enough, you'll end up with a list of commonly used or most recently used functions. So I'll just click on correlation. What's my first set of data? It's this one. I'm going to correlate the brothers with the sisters. So let's see what the correlation looks like. And we put OK. Got a big number. Let's make this a little bit smaller. 0.56. And if you want to impress me, and you always want to impress me, I'm going to make this a little bit bigger. Correlation is, I'm going to just move that over to the other side. Okay. So we have correlation is 0.056. Now, you should know That's not a very good correlation. If it's not close to 1 or -1, it's not very good. So that should give you an idea of what we're going to get for our final results in terms of our decisions that we're going to make. Now, let's look at regression. So we take a point, any point. Look at my arrow. My arrow is right on the point, right click, and I'm going to add a trend line. Now, I took this piece by piece in the first video of this chapter. I'm going to take it all at the same time. Linear. I'm going to display the equation, and I'm going to display the r² value. So let's do that. Here's my equation. Let's put that up here so we can see it. Actually, put it at the same time. They put the r² there too. Okay, here's the equation. 0.527x plus 27.635. All right. That y stands for sisters' heights, and the x stands for brothers' heights. The r² is 0.3114. That means about 31% of the line explains the data. Not very good. So you may want to adjust your thinking about this. By the way, I hate this thing. There, makes your graph look much nicer. Okay, so now it should look a little bit like this one. And now we're going to do an example. So this is from 534, and I'm using an example here. Let us use the equation to make predictions. What if a brother's height was 74 inches? What would his sister's corresponding height be? Let's go back to the graph. What if it's 74 inches? Right about there. Okay, we're not extrapolating beyond our range. If we were like 80 inches, keep going up and so on, and you know you can't go 100 inches because people are getting freaky high at that point. But let's say 74. What's this line? What's this point over here? Or you could go about 64.5 inches. What would be the corresponding height of his sister? So this is what I did here. What if a brother's height was 74 inches? What would his sister's corresponding height be? This is the regression line we got right up here. So I'm going to use that. Look at the graph carefully and you'll see that y is dependent. Y, the sister's heights, depends on the brother's heights. So y depends on x. Y is the response variable. X is the explanatory variable. This represents the sister's height. You can see that therefore in a regression equation, I plug in the numbers. The regression equation, 66.6, so I rounded it off to 67 inches as the height of the sister. So 67 inches is about, so if we keep going to 74, right about there, you can see it's about 67 if we went across. But we're using the equation. So that's how you find it. One last thing, as I said in the PowerPoint demonstration, there's a site over here, and when you click on that site, and I will send you these materials, the PowerPoint and also the example here. It comes up to this. This is from the Journal of Anesthesiology, and very simple article. It's kind of like a little elegant article, and it's something that if you wanted to research, I just put in keyword infant weight height, and I got this one. Very simple abstract, which is what you should have in your research paper. This is like the teaser. You write their abstract after the last. It's the last thing you write, by the way. It's just a little teaser, like a commercial. Why should I read this article? So this person is going to look at human body surface area and see if there's a linear relationship. Aha! That should be familiar, between the body surface area and the weight in infants between 3 and 30 kilograms. This is his introduction. This is his theory. This is what he's thinking. He's using previous sources of information. There are his sources. You can see that. It's kind of cool because it comes up. It won't come up for you. He predicts that this equation will work. Going on, tells us what he did, his methods, and here's a linear regression line. In fact, it looks just like what we've been doing. Let's click it on and see what it looks like. Look at that. He's got a title. He's got a label plus the units. Same over there, and there he is. He's got his line of regression, and he's got an r² value of 0.97. 97% of the data that he found can be explained by the line, especially over here in the lower weight area. So that's what he's got. So he's got this equation. It's kind of cool. He talks about it, which is what you should do. Talk about your results. This is your decision-making area, and then he's got his references. So that's basically the whole idea of what you're trying to do in this chapter. I don't want you to start solving equations and going nuts with it. I just want you to be able to use Excel. Thanks. Have a good week.